questions 11 through 20 on the 2003 grade 10 Cayley math contest. Let n be 10 to the power 3 all the way down to 10 to the power 9. The sum of the digits of n is. So what I'm going to do is write each of these, but I'm going to write them in a way so that they're sort of lined up. Now the hardest part is just keeping track of the zeros. 0, 0, 0, 0, 0, 0, 0, 0, 0. So this is this guy right here. The next one, 8 zeros. Okay. Next one, 7 zeros. 6 zeros is the next one, I think. I was already getting confused. 5 zeros for the next one. 4 zeros. And the last one is 3 zeros. Okay. So I've lined them up, and then now I can add them. So this guy right here, this column is 0, 0, 0. I got 1, 1, 1. Okay, 1, 1, 1. So basically, the addition was pretty straightforward. Now this is n. They want you to find the sum of the digits of n. So add up these digits, basically. Right? So we got 1, 2, 3, 4, 5, 6, 7s. 7 times 1, and the zeros don't add anything to the sum. So 7. There you go. Number 11, the answer is E. Points A, B, and C lie on a straight line. The value of A is. So any line is of the form y equals mx plus b. That would be the equation of any line. And then we've got 3 points, A1, 9, 0, and minus 3, 4. So we can just substitute these in and get everything we need, basically. So where do you want to start? I'll just start right there. So substitute that point in when y is 4, x is minus 3. So there we go. Oh, I put in the x twice. All right, plus b. And then I'll substitute this guy into y equals mx plus b. So that would be 0 is equal to 9m plus b. So these two equations, probably subtract them, and you'll be able to get m. So 4 minus 0 over here, minus 3m minus 9m, and then plus b minus b. So the b's cancel. This just becomes 4, and this is minus 12m, and therefore m is equal to 4 over negative 12, and that is also equivalent to a negative 1/3. Okay, I think we are very close here, just a couple more letters. B and A, I think. Next one I'll try to find is B. So our equation now is y equals negative 1/3 x plus b, because the slope was negative 1/3. And then I'll substitute this one, 9, 0, that point. So 0, negative 1/3, x is 9 plus b. So this looks like 0, negative 3 plus b, and therefore b is equal to 3. All right, we are pretty much at the last step now. We have our equation, y equals minus 1/3 x plus 3, and then just substitute that in to get the value for a. So y is 1 minus 1/3 a plus 3. Put this 1/3 over on the other side. 3 minus 1 is 2, and therefore a is 2 times 3, which is 6. So number 12, the answer is D. In the diagram, ABCD is a square with a side length of 10. If AY equals CX equals 8, the area of the shaded region is. So we have AY right here is equal to CX, which is right here, and they've given you that they are equal to 8, those numbers, the lengths. And they want you to find the area of the shaded region. Okay, not a problem, I think. Now, we are told that ABCD is a square of side length 10. So the entire figure is a square of length 10, so its area will be 10 times 10, which is 100. So if we can subtract these triangles from that big square, we can get the area of what's left over, which is the shaded region. So area of shaded region, AS, is the full square minus the triangle ABY minus the triangle DCX. Correct? So ABY, 1/2 base times height, 8 times 10. And then DCX, that triangle, 1/2 base times height. That's 10 also because it's a square. So same thing, 8 times 10. So you've got 100 minus 40 minus 40, and therefore that is 20. So the area of the shaded region is 20, and that makes number 13 have the answer B. Carly takes 3 steps to walk the same distance as Jim walks in 4 steps. Each of Carly's steps covers 0.5 meters. How many meters does Jim travel in 24 steps? So let this line represent Carly's 3 steps. So just divide this into 3. So Carly, Carly, Carly. These are her 3 steps. And then I'll draw a separate line for Jim right below it. And that line, he's going to take 4 steps. So let's see, approximately like this. These are his 4 steps. Jim's first step, second step, third step, and fourth step. Now these 2 lines have the exact same distance, right? Carly's 3 steps are the same as Jim's 4 steps. Now they tell you that each of Carly's 3 steps is 0.5 meters, so therefore we can use that to figure out how far is Jim's step. So the mathematical formula will be 3C is equal to 4J, and then C they tell you is 0.5, so I plug that in, and we got 4J there. So 1.5 is equal to 4J, and therefore J will be 1.5 divided by 4, which is 0.375. So each of Jim's steps is 0.375 meters. Now they want you to figure out how far does he travel in 24 steps. So 24 times each step, which is 0.375, is the required distance, and 24 times 0.375 is equal to 9. So 14, the answer is B. In the diagram, L1 is parallel to L2 and BA is equal to BC. The value of X is. So lots of places we can start and a lot of directions we can go in. First, I'll just do this one right here. Angles about a line are equal to 180. So if this is 70, that means this has to be 110. And then this angle in here, which I just drew as 110, and this angle will be the same. Why? Because they are corresponding angles. And that, of course, is true because L1 is parallel to L2, and that's what these little symbols mean. All right? So that means this is 110, right in here, 110. Now I want you to look at triangle BAC right there. That triangle is isosceles. That's what these 2 little symbols mean, that those 2 sides are the same. So if it is indeed isosceles, that means that this angle and this angle are the same, that I've denoted as y. So that basically means that y plus 110 is equal to 180. So 2y is equal to 70, and therefore y is equal to 35. Now we want x, which is this guy all the way over here. Now opposite angles are the same, so that means this is x. And therefore now we can just use this big triangle right here to figure out x. The sum of the angles will be 180. So 110 plus x plus y is 180. Y we know is 35. So 110 plus x plus 35 is equal to 180. So we got 145 plus x is 180, and therefore x is equal to 35. So 15, the answer is A. The value of this expression is, so we are going to have to probably do some manipulation of these numbers, because we're certainly not going to calculate each individual value because that would be too large. So the first thing I'm going to do is break this guy up right here. That one can be broken up into 2 times 3, and that will be all to the power of 2002. 2 to the power of 2003 we can't do much with yet, and neither can we do much with 3 to the power of 2002 because 2 and 3 are prime. But the 4 can be changed into 2 to the power of 2 to the power of 2003, like that. Okay, so we modified it a little bit. That becomes 2 to the power, you multiply them, 4006, 3 to the power of 2002. And then this one can be broken up into 2 to the power of 2002 times 3 to the power of 2002 times 2 to the power of 2003, like that. And then this cancels with this guy. And then we can combine these two. So the top is just 4006 and the bottom is 4005. And then this is just 2 to the power of 4006 minus 4005, like that. So this becomes 2 to the power of 1, which is just 2. So 16, the answer is B. In the diagram, the 4 circles have a common center and have radii 1, 2, 3, 4. The ratio of the area of the shaded regions to the area of the largest circle is. So they want us to find area of the shaded region all over the area of the largest circle, and I'll write that as pi r squared. So find this. Well, pi r squared is pretty simple because the largest circle has a radius of 4. So that means that will be 16 pi. So now let's concentrate on finding this area of the shaded region. So how are we going to find the area of the shaded region? Well, let's just do the easy one first. That's this guy right here. That's just pi r squared. And the radius, that's the smallest circle, so that radius will be 1. So that becomes pi times 1 squared, which is just pi. So we got part of the shaded region here. We got pi. And we have to add, obviously, this region right here. So how do we get that one? That one will basically be, I'll show you, the area of the second largest circle, subtract from it the area of the third largest. Okay, I hope that makes sense. So if you take the area of the second largest and then subtract all that, you'll get that shaded region. So let's do that. That would mean it's pi, what is the radius of that third? It's 3. Pi 3 squared minus pi, this is going to have a radius of 2 right there, 2 squared. So this is 9 pi minus 4 pi, which is 5 pi. So 5 pi is the area of that shaded region. So this was pi, and this shaded area is 5 pi. Okay, so the area of the total shaded region is 6 pi, and we're dividing by the area of the largest circle, which we already determined to be 16 pi. The pi's cancel, and then you get 6 over 16, which is 3 over 8, and I believe that's it. And they want to write it in this form, 3, 8, which is fine. It's the same thing. So 17, the answer is E. If 496 is equal to 2 to the power of m minus 2 to the power of n, where m and n are integers, then m plus n is equal to. So the first thing I noticed is that you have two numbers that you're subtracting, and they're both powers of 2. So if I can list the powers of 2, then by inspection, I'll be able to figure this out. And I think for this question, that's probably the best way of doing it. So here we go. And I think once I get up to 1024, that's more than enough. So these are all powers of 2, right? This is 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, and so on. So I've got to take two of these numbers and subtract them, and the result has to be 496. All right. Well, 496, let me write it out, and then we'll stare at this for a little bit. 496 is equal to some number, and then from it you subtract another number. So this first number obviously has to be greater than 496. I hope that makes sense. So it could be 512 perhaps, right? So let's put that in. And then from it, I've got to subtract another one of these list members. Which one? Well, let's see. If I put a 16, that would work. It would make it 496. And that's it, just by inspection alone. So now all I have to do is figure out m and n. Well, what is 512 in terms of a power of 2? Well, it was 1, 2, 3, 4, 5, 6, 7, 8, 9. 2 to the power of 9 is 512. And then what about 16? Well, that's 2 to the power of 4. Like that. Right? So that means my m is 9 and my n is 4. So m plus n is 9 plus 4, which is 13. So number 18, the answer is A. The product of the digits of a 4-digit number is 810. If none of the digits is repeated, the sum of the digits is. Okay, so you've got a 4-digit number like that, A, B, C, D. And if you were to take these individual digits and multiply them together like that, it would result in 810. And they eventually want you to figure out what is the sum. So A plus B plus C plus D. All right, another question that most likely is done by inspection. What I'm going to do, the first thing, is break up 810 into its factors, prime factors. So 2, and that leaves what, 405, so 5. And then 405 divided by 5, and you get 81. And 81 is 9 times 9, which is basically 3 times 3 times 3 times 3. Like that. Okay. Now using these prime factors, I've got to figure out what A, B, C, and D are. All right, let's figure this out. I'm going to keep a 5 here. If I use 2, then I'll have 9 and 9, but I cannot repeat the digits. See, that's a key criteria there. If I use 3, but then this is going to be too big, that's going to be 27. That's much greater than a digit. So that makes me think that 2 is not a good number to use. But if I multiply 2 and a 3, I'll get 6. And let's see if I can make this work now. Then I'll put a 3 down here. And then a 9. Those ones, they're perfect. There you go. 5 times 6 times 3 times 9. Those will work. So what does that mean basically? It means that A, B, C, D, it doesn't really matter the order, are represented by those 4 numbers. And now we want to find the sum. No problem. 5 plus 6 plus 3 plus 9, and that is 23. And this 23 is worn on his jersey by a very famous basketball player. If you know who that is, you can type it in the comments below. So the answer to number 19 is C. A car uses 8.4 liters of gas for every 100 kilometers it is driven. A mechanic is able to modify the car's engine at a cost of $400 so that it will only use 6.3 liters of gas per 100 kilometers. The owner determines the minimum distance that she would have to drive to recover the cost of modifications. If gas costs $0.8 per liter, this distance in kilometers is between. So we have to figure out a distance. So the very first thing is that this car was 8.4 liters for every 100 kilometers. So you had to use 8.4 liters of gas for every 100 kilometers that you drove. And then this car was modified at a cost of $400 to make it, I guess, more fuel efficient. Is that the term? I don't even know. So now it only has to use 6.3 liters of gas for every 100 kilometers. Okay, great, right? But you spend $400 to do that. So what they want to figure out is how long do you have to keep driving to recover those costs? Well, in a simple comparison, if you have 8.4 liters for every 100 kilometers, that would mean that for every X liters, you can drive D kilometers. And D is what we're trying to figure out. Okay, so this is our great variable here that we want to figure out. So keep that in mind. And then now let's work with each of these individually. For the first one right here, we have 8.4 liters per 100 kilometers. And we want to multiply that by D kilometers. All right? And that basically will allow us to figure out how much money we spent. Okay? So that gives me 8.4 liters. The kilometers cancel each other, so it just becomes a number, D over 100. Just a number. So this is how many liters I need to use to drive D kilometers. Whatever D is D 100, 1,000, 20,000, whatever it is. But now I'm interested in the price, right? Because I have to figure out how can I recuperate $400. So I have to convert this now to a price using our cost. The cost is $0.8 per liter. All right? So now, basically, the liters cancel in terms of the units, and then you get something all in terms of dollars. And that is going to be 0.0672, and don't forget the D. All right? So 8.4, 0.8, and 100, those were the numbers used to figure out this 0.0672. And in a very similar way, I'm going to do the same thing, but using this fuel calculation. 6.3 liters over 100 kilometers times D kilometers is how many liters I need for D kilometers. And that would be 6.3 D liters over 100. Okay? And then, very similarly, I have to multiply this by $0.8 over liters, and this will give me a price, an actual price. The liters cancel as the units, and this becomes 0.0504 D. And remember, D is just a number. It's how many kilometers we're going to drive. So this is how much it costs with the old fuel efficiency This is how much it costs with the new fuel efficiency. So what we need to do is figure out D, and you get D by subtracting them. 0.672 minus 0.0504 is equal to $400. And don't forget the D. For each of these, you got a D in there. Okay? And this basically becomes 0.0168D is equal to $400. And if you divide through, you'll get D is equal to 23,809. All right? That is in kilometers, and that is the distance that you have to drive in order to recuperate your costs. So what are they asking? Distance in kilometers is between. So we got 23,809, and that is between this one right here, 22,000 and 26,000. So the answer to number 20 is D.